Hi and Assalamualaikum everyone. We are from Group 1 and today
we will be presenting
a topic related to electromagnetic propulsion.
Ta-da!
Assalamualaikum and hi everyone. My name is Nata Singputri binti Azmi and our group will be presenting on electromagnetic propulsion under the topic of scientific research and space exploration. Electromagnetic propulsion is a technology that uses electric and magnetic field to generate thrust and move spacecraft through space. Unlike conventional chemical rocket, this technology uses electricity to accelerate charged particles, making it much more fuel efficient.
My name is Nurul Farzana. So for scientific principle, electromagnetic propulsion works based on the interaction between electricity and magnetism. In the system, charged particles such as ions experience a force called the Lorentz force when they move through electric and magnetic fields. The Lorentz force is represented by the equation shown on the slide, where F is equals to Q in brackets E plus V times B, where F is force, Q is the charge of the particle, E is the electric field, V is the velocity, and B is the magnetic field. This force accelerates the ions to very high speeds. As the ions are expelled from the engine, thrust is generated. According to Newton's third law of motion, every action has an equal and opposite reaction. Therefore, when ions are pushed backward, the spacecraft moves forward. Unlike chemical rockets that rely on combustion, electromagnetic propulsion uses electrical energy to accelerate charged particles, making it a highly efficient propulsion system for space exploration. Next, ion acceleration. Ion acceleration is one of the most important processes in electromagnetic propulsion. Firstly, neutral gas such as xenon is ionized to create positively charged ions. These ions are then accelerated using strong electric fields, allowing them to reach extremely high velocities. Magnetic fields are also used to help control and direct the movement of the ions, ensuring that they travel in the desired direction. After acceleration, the high-speed ions are expelled from the thruster to generate thrust. Ion acceleration is important because higher ion velocities result in greater momentum transfer. This means the spacecraft can generate thrust more efficiently while using less propellant compared to conventional chemical propulsion systems. As a result, electromagnetic propulsion is particularly suitable for long duration and deep space missions.
Now that we know more about the general concept of electromagnetic propulsion, how can this be implemented in the real world? The first one is ion thrusters, which use electric fields to accelerate ions and produce propulsion. Some examples of technology that uses ion propulsion systems are the Dawn spacecraft and the Deep Space One spacecraft. Other than that, there is also Hall effect thrusters, which use magnetic fields to trap electrons and improve ion acceleration. Hall effect thrusters are applied in satellite station keeping, orbital adjustments, and deep space missions.
What makes an ion thruster different than other types of thrusters? Sure, well first let's remind ourselves how a regular rocket engine works. You take a gas and you heat it up or you put it under pressure and you push it out of the rocket nozzle, and the action of the gas going out of the nozzle causes a reaction that pushes the spacecraft in the other direction. With ion engines, instead of heating the gas up or putting it under pressure, we give the gas xenon a little electric charge. And then they're called ions, and we use a big voltage to accelerate the xenon ions through this metal grid, and we shoot them out of the engine at up to 90,000 miles per hour. And the engine pushes on the spacecraft as hard as this single piece of paper pushes on my hand. In the zero-gravity, frictionless environment of space, though, gradually the effect of this thrust builds up. At full throttle, it would take Dawn 4 days to accelerate from 0 to 60 miles per hour. The ion engine gives us the maneuverability to go into orbit, and after we've been there for a while, then to leave orbit and go on to another destination and do the same thing. In 57 years of space exploration, Dawn is the first mission targeted to orbit any 2 extraterrestrial destinations. It wouldn't be possible without ion propulsion.
Based on research findings, scientists continue improving thrust efficiency, power systems, and long-duration reliability.
Move on. Now we will talk about benefits and challenges of electromagnetic propulsion. As we evaluate the viability of advanced propulsion technologies like ion engines, it's crucial to weigh their unique advantages against their operational constraints. Let's look at the two sides of the coins. On the benefit side, this technology is a game changer for efficiency. It's offers incredibly high fuel efficiency, which allow for significantly longer mission duration without needing massive fuel tanks. Because we need less propellant, we drastically reduce the lower spacecraft mass at launch. This makes it uniquely suitable for long-term deep space exploration where traditional chemical rockets just aren't practical. However, these benefits come with distinct challenges. First, they produce a very low thrust output, which results in quite slow acceleration. They take a long time to get up to the top speed. Furthermore, running this system requires significantly electrical power. Because of that low initial thrust, it's important to note that they are absolutely not suitable for spacecraft launch from Earth. They only work efficiently once they are already out in the vacuum of space. This brings us to where this technology is heading next. Now, we will continue our discussion with talking about future development of electromagnetic propulsion. Looking ahead, the roadmap for this propulsion system points to some incredibly exciting future developments. Engineers are currently developing next-generation advanced ion engines and pairing them with nuclear electric propulsion system. By using a nuclear reactor to generate the massive amount of electricity required, we can overcome the power limitation we just discussed. What does this mean for practical space travel? First, it's opened the door for much faster travel to Mars, cutting down transit times and reducing radiation exposure for future astronauts. Beyond Mars, it's laid groundwork for highly ambitious deep space exploration missions, potentially pushing our reach even further to enable potential mission beyond our own solar system. We are truly on the cusp of the new era of interstellar discovery.
In conclusion, electromagnetic propulsion is a promising technology that uses electric and magnetic field to generate thrust and accelerate charged particles. Its high fuel efficiency makes it particularly suitable for long duration and deep space mission. Although challenges such as low thrust and high power requirements still exist, ongoing research and technological advancement are expected to make electromagnetic propulsion an important part of future space exploration.
Thank you for watching us.
See?
Again.
Bye-bye.
Bye-bye.